Yo, what is up YouTube, and welcome back to the 5th video of this video series where I'm showing you from start to finish how to develop out a really robust and pretty multi-sig wallet application that runs entirely on the Ethereum blockchain. So if you don't know me, my name's Migrating, and on my channel Web3 Simplified, I teach you blockchain development. So if that's something that sounds interesting to you, then I'd really appreciate if you just take the time to like this video and subscribe, just because it helps this channel out with the YouTube algorithm. So before we get in, just recall in the last part we actually finished the smart contract part of this application, aka we actually finished the multi-sig wallet logic. And in this video is going to be serve as sort of the transition from the smart contract backend to developing out the UI. So in this video, what we're going to be doing is we're going to be taking our code from Remix and bringing it into VS Code and deploying our contracts with Truffle, which is, you know, we installed that in the first video, and Truffle just allows us to deploy our contracts onto either like the mainnet or testnet, but in this case we're actually going to be using a local development chain through Ganache. So that's what we're going to be doing in this video. We're just going to be taking our code and deploying it in VS Code with Truffle, and then the second part of this sort of in between phase, we're going to set up all of the requirements that we're going to need to actually start developing the front end user interface. So I'm just going to get started. So I'm going to switch to my screen here. You will see that I'm in the GitHub repository for this YouTube series. So I pushed up the code from the state of the last video. And if you've been following me, then you can just use the code that you have. But what I'm going to do is I'm going to come in here and go to video for code. And I'm going to open up these two files here. So what we're going to do is we're going to copy all of this code into a text editor. So I'm using VS Code. So what we want to do is I'm just going to open up this folder here where I'm, edit all my videos for this project, and I'm going to create a new folder. So you can go anywhere you want, maybe on your desktop or documents or wherever you want to create this folder, and let's call it multisig wallet project. And when we create it, just open up a terminal in this folder. And what I'm going to do is I'm going to make two directories. So the first directory that I'm going to make is for the backend. So let's make a directory called make dir, and we'll call it backend. And then I'm going to make another directory, make dir, and I'm going to call this front end. Or if I can, I'm going to do that again because I spelt it wrong. And then what we're going to do is we're going to actually cd or change directory into the backend. So we'll just type cd and then type b, and then if you hit tab to autocomplete, you'll be able to go into the backend. And now that we're in here, if we type ls, you can see there's nothing in this folder. So the first thing that we need to do is we need to initialize a truffle project. And what this will allow us to do is it will create a few requirement files that will allow us to effectively take our smart contract code and deploy it to either the Ethereum blockchain, be it a mainnet or testnet, or it will allow us to locally deploy our code, which is what we're going to be doing. And we're going to locally deploy our code with Ganache, which is a local development blockchain that runs on our actual computer. So to initialize a truffle project, what you want to do is write truffle init. And just while this runs, if you don't have Truffle installed on your machine, go back to the first video where I tell you to install Node.js. And then once you've Node.js installed, you can install Truffle by just typing npm install truffle, and that will install the Truffle framework for you. Okay, so we can see that it successfully happened. So if we press ls now, you can see that we have a folder called contracts, migrations, and test. So there's one other thing that I'm going to do, and I'm going to type npm install. Actually, I'll do that when we get to it. I'm going to open up this in VS Code. If you have VS Code, you can just type code and space and then a dot, and it will open up the folder in VS Code for you. So we're going to come in here now and we can get rid of this. And if we go into contracts, you'll see that there's a file called migrations, and you will never have to look at this file or change this file. This pretty much is a file that allows Truffle to deploy our contracts onto, you know, a development chain such as mainnet or testnet or whatever. In our migrations, we then have the migration JavaScript file, which actually deploys our smart contracts. And then we have a test folder which has nothing in it. And we usually use the testing folder to write tests to make sure our smart contracts behave as we want them to. And then this file here, truffle config, this just is a file that allows us to change the default parameters that we use in order to deploy our contract. So we can change, you know, which network we want to deploy to. So you can see here, this says development, or we can, you know, specify Ropsten, for example, which is a testnet. Maca here, this is just for testing. We won't be needing this. We can specify the solidity compiler version. We can do a lot of other things in here, such as you know, set up a HD wallet provider using Infura, which we'll be doing later in this course. But the only thing that we need to do in this file before we even get started is I want to come in here and uncomment out this development environment here, and we want to change 8545 to 7545, and you'll see why we're doing this in a minute. And then we want to change our compiler version to 0.8.7 because that's the compiler version that we used while we were using Remix. If you're looking at this video in the future, or maybe you've used a different compiler version, then the version that you declare at the top of your contract, aka pragma solidity, and then the version needs to be the same as the version that you declare here. So we're going to save this file, and then what we're going to do is we're going to go into our contracts folder, and we're going to make two files for the, you know, the files we developed in Remix, the link token and the multisig contract. So I'm just going to call them link.sol and multisig.sol. And then what we're going to do is we're going to come into the GitHub repo, and I'm just going to copy this code. You could copy it directly from Remix, but it's just handier for me because I already pushed it up here. And we'll paste this into the multisig file. And then we'll come back and we'll grab the link contract, and we'll do the same. So we'll go into link, and we'll paste this in here, and boom. So now what we want to do is we want to go into the migrations. So in order to deploy this, we need to make a migrations file for each contract. So you have to make a migrations file for every contract that you want to deploy. So we're going to have to make 3 migration files. We're going to have to make a migration file for the link contract, or the link token. We're going to have to make a migration file for our multisig wallet, and then one for the multisig factory. And before I continue, I should say that we actually don't really need one for the multisig wallet, because we won't be interacting with that contract directly in the final app. We'll be interacting with it through the factory. But in order for me to test my code, I'm going to deploy it, and you'll see what I mean in a minute. So in order to do this, let's just make a 3 migrations file. And it's very important that when you make your migrations that you order them. So don't just type out a name and then name it whatever. You need to deploy 2. So there's initial migrations will be always 1_initial migrations, but every contract that we want to deploy after this, we need to order it. So 2, 3, 4. So 2_link _migrations. You can name it whatever as long as you have the 2 in front. And this is a JavaScript file, so we'll say .js, and then we'll make another one called tree wallet migrations .js, and then we'll make one more called 4, and we'll call this one multisig factory migrations .js. And all we're going to do for these files is we're literally just going to Control A and Control C the initial migrations, and we're going to paste them in to our files one by one. And then all we have to do is just right click on this migrations word here and go change all occurrences, and then replace this word with the name of the contract that you want to deploy. So for our link contract, we simply just called it link. So do that and press Control S. So you can see here, we just called this contract link. For our multisig, I actually have this 2 eyes. I'm going to change that. So for our multisig, you just want to copy this, and then come into the wallet migrations, which is tree, and then just replace the migrations with the multisig contract name. So it's multisig, like so. And then lastly, for the Oh, I made a mistake. This should be .js. And then for the factory, multisig factory, just paste this in, go back to your multisig contract, and then just grab the name of the factory. And then come in here and change all the currencies to multisig factory. And boom. Now there is ways you can deploy your contract in more complex ways. Like for example, we could deploy this and then under this we could write logic to actually, you know, initialize our contract in a few ways. Maybe we'd want to call a few functions or, you know, save time by in testing by actually like, you know, setting up a few things. We could do all that here, but just for the sake of this series, I'm not really going to get into it because we don't really need to. So once we have this set up, there's one more thing that we need to do before we can try and deploy this. And what we are going to do is if we come over here to link, you can see that we're using a we're linking in the ERC20 Open Zeppelin contract from an actual web link. This won't work when we have it set up in VS Code. So what we need to do is we need to install the Open Zeppelin contracts as a project dependency. And in order to do that, we need to use the Node package manager. So if we open up our terminal and in order to initialize NPM, or in order to be able to install different project dependencies with the Node package manager, we need to type npm init. And this will create a node project, and then we can just, you know, click through all these. It doesn't matter. These are just like things to set it up to. We don't have to do any of this. And then when we do this, you'll notice that we get a package.json file. And in this package.json file, there's different things here, such as it gives us the name and all the things that we just initted right there. And then we can do various things here, like set up scripts that we can run. And here, although it doesn't show it, when we install the Open Zeppelin contracts, there will be a new section here that will come up called dependencies, and that's how we'll access the Open Zeppelin contracts. So if we type npm install and then go at Open Zeppelin / contracts, then and run this, then it will install the Open Zeppelin contracts so we can use them. And you can see our package.json got updated, and now we have a dependency of Open Zeppelin contracts. So what we can do here now is we can go back into our link.sol and get rid of this. And the way that we you know, get the ERC20 contract into this file is we need to take the path. So if we go into node modules, you'll see that we have Open Zeppelin, and the ERC20 is in token ERC20 and ERC20.sol. So in order to get this path into our contract here, what we can do is we can just type in double dot, and then this will automatically come up, and we can just, you know, tab in to where we want. So it's in node modules. Once you get down to node modules, press tab, then backslash, and then this will come up, and just keep typing tab, backslash. So we want to go to the contracts, tab, backslash, and we want to go into token, tab, backslash, ERC20 tab backslash, and ERC20.sol, and then just type in the .sol because it won't autocomplete when you tab the last time. And then we can copy this import, and then we can go into our multisig, scroll up to the top, and delete both of these, and then copy this, and we need the interface as well, so just type in I. And boom, I think we've done everything that we need to be able to deploy this. So in order to deploy this, the next thing that we need to do, now that we've set up our migrations, we've taken over our contracts, we've done everything that we need, we specified the version that we want to compile with, the next thing that we want to do is actually set up the Ganache local development blockchain that we installed in the first video. So again, if you missed the first video, I'll leave all the links down below so you can install all this stuff. But we want to open up Ganache because Ganache is a local blockchain that runs on our machine, and we can use it to do quick testing. So for some reason, Ganache, where is my, oh, here we go. So you want to open up Ganache, and it might take a minute or two to open depending on how quick your machine is. It usually takes like 30 seconds to open on mine. It's not the quickest thing to open, so I'm just going to cut to whenever it does. Okay, so whenever Ganache opens, you'll be faced with this screen here, and we have two options. We can quick start, or we can create a new workspace. Now, I would just go and click new workspace, or actually just go on quick start, it doesn't matter. I already have a workspace open, so I'm just going to click on that for me, but if you click quick start, it will be the exact same thing. And when this opens, this is going to open up, this is going to start a local blockchain, which is, pre-appended with 10 accounts that all have 100 Ether. And we can effectively use these accounts to send transactions with our app, all on this local blockchain. And that's how we test our contracts to see if they work. And when they do work, if we want to then deploy on testnet to simulate a more real environment, then we can actually deploy on testnet and we don't use Ganache. And then once we've tested our contracts in testnet to make sure they work even better, then we can finally deploy to mainnet. So there are usually the 3 phases of deployment. So this is what Ganache looks like when it opens, and you can see here that the RPC server, which is the RPC node, that's what we use to connect to the blockchain. You can see that this is at 127.0.0.17545. So that's why we changed this port to 7545, because that's the specific server for Ganache. So if we come back in here to hook up your project so that you can use these accounts with your Truffle project, is just click on this settings button here. And what you want to do is add a project, and we can come into FYP. No, it's not. It's in YouTube. Sorry. We can go into wallet videos, and it's in multisig project, backend, and click on the Truffle config file, open this up, and then press save and restart. And when this loads back up, then we can effectively use these accounts with Ganache to test our smart contracts in the Truffle project that we've set up. So now that we have this done, I'm just going to wait for this to set up just to make sure that everything will work. There we go. Okay, so when we've done that, you want to go into your terminal again and write truffle console. And this will initialize a connection to that Ganache instance that we've created, and you'll know you're in it successfully when this comes up. So in order to deploy your contract, you can try truffle migrate and then type -- reset. The first time you deploy, you can just type truffle migrate, but I always use the reset flag, because if you're deploying like your contracts and maybe the first 3 compile, and if you don't specify the reset flag, then it won't change the ones that have compiled. So if you make any changes and then in your contracts and you don't specify reset, then the changes won't get overwritten. So it's always good to specify the reset flag, just to always make sure you're deploying the most up-to-date version of your contracts. So this will compile all of these different contracts and make sure the version in Truffle is the same as the version, the Pragma version in your contracts. So they've successfully compiled, and now these are going to deploy. And you'll notice that when they compile, we get a build folder here, which pretty much just has all the JSON information for all the contracts. And we use this to extract, certain information about our contracts when we're going to be creating instances of them when we're using the front end interface, and we can access different things about each contract through these JSON files. Okay, so this might take just a second, because it's the first time I booted up this project. So I'm just going to cut to whenever these contracts do or don't compile or migrate, sorry. Okay guys, so my contracts are starting to deploy here now, and you'll see that just one by one, all of these messages will come up. And when we're finished, we'll get this little summary here, which means that things were successful. So if we come up, the first contract that will deploy will always be the initial migrations. And then it's just going to deploy our contracts one by one from the migrations file. So the second one is link, and you can see we can get the transaction hash, which means it's like the receipt of the deployment. Because when we deploy a contract, it effectively is a transaction. And then we get the address, things like our account, the balance, and the gas and all that stuff. And we get this for each and every contract that we deploy. So now that we have these deployed, which means that these are contracts which are on our local Ganache blockchain. So we can now interact with these contracts to, test them. And ideally, if we were going to test them, I would write a specific file, JavaScript file in this test folder for testing. But if I was to do a robust test, it might take 2 videos for me to explain it properly. And this series is already going to be another 7 or 8 videos long, especially when we start developing out the UI, which is the most tricky part of this entire course. So I'm going to test really quickly in my console. And the reason I'm going to do that is because we already incrementally tested our contracts after each episode. So we know that the deposits work. We know that the add remove owners works. We know that the approvals work where we can't approve the same one twice. All of that. We know all that works. The only thing we have to sort of test now is the multisig factory. So whereby we can add permission for certain owners to access wallets, and we can remove permissions from owners to access certain wallets based on if they are a member of the owners array in our base multisig contract. So what I'm going to do here is I'm going to deploy the link contract. I'm going to make an instance of the link token contract, and I'm going to make an instance of the multisig contract and the factory contract. And we're going to use the multisig factory or main multisig wallet contract to test those features. And what we're going to do is I'm just going to double check that we can create, approve, and deposit, withdraw, and all that stuff. And I'm going to double check that we can do the same with ether and link. And then I'm going to check the permissions. If we remove an owner from the wallet owners array, well then does that owner still have access to the that wallet address in the factory contract? Things like that. So we're going to start here, and to create an instance of any of these deployed contracts, what we can do here is we can just type let. So this is JavaScript notation, so we're going to let let's say link equals, and then in order to make an instance of our link contract, we can just type await link, which is the name of the contract, dot deployed, like so. And you'll notice if we go in here, you can see that this is going to deploy it, and then we create the instance by typing out this. So if we do that, you'll see that we get a little message saying undefined, but if we just type out link, you can see that it will give us the complete contract with all of the methods or functions that we can call. All of these are from the ERC, because remember we inherited the ERC20.sol contract, so all of these come from that. But you can see we have all of this information, and we should have like the address and stuff at the top and all of the events and stuff. So we can actually type link.address as well, and we can get the contract address. And this, it's important to note that this is an instance of our link contract. We could come in here and say let link1 equals await link.deployed, and we can make two instances like this. And then if we went and got link1.address, you'll notice it's the same. Now you never really would do this, but it's just important to drive home that when we initialize this, it is an instance, one particular instance of our contract. So let's do the same. We'll say let multisig wallet, and we'll say await multi sig, dot deployed, and that will deploy us our actual wallet contract. And then we can do the same for the factory, so we'll just autocomplete that, and we'll say multisig factory, and we'll call this multisig factory like this, and then boom. So if we get the addresses of all of these now, so we can say or I'm just going to copy it to save me typing it out. So we get the address of the wallet, and then we can get the address of the factory like this, and boom. So we have the address of link, the address of our wallet, and the address of the factory. Now I'm only going to use the factory to call the wallet owners function. So I'm going to use the factory to call the function that returns us all of the given wallets that a user has access to. We're not actually going to interact with the factory in this test, which is actually the opposite of what we're going to do in the real application, but I'm only doing this for testing purposes. So let's just come in and use the multisig. Let's just test our multisig wallet contract. So the first thing we can say is, let's say await multisig wallet. I'm just going to copy this. So let's say await multisig wallet dot get owners, get wallet owners, I think it's called. And you can see that, boom, we have one wallet owner, which is account 0xD1, which is this account here, and he is the person who effectively deployed the contract. So right now, this is the only owner of the multisig wallet. So let's just do something. So let's look at accounts 2. So accounts 1 is this address here. So let's see if this account here has access to this multisig wallet. So to do that, we can call our multisig factory. So we'll say multisig factory, and let's call get owner wallets, and let's pass in the account of the person we want to get the wallets for, which is account 1 in this case. And you can see this returns an empty array because we effectively haven't created any wallets as this owner, or we haven't added this owner to any other wallet instances. So now let's go and get let's add in, using our multisig wallet, let's add, or where is it gone? So multisig wallet, or we'll just get it here, and let's add an owner. So we'll say add wallet owner. I think it's called that, yeah. And what we'll do is we'll pass in the wallet owner we want to add. So let's say accounts of 0 or of 1, because we already are an owner's account 0. And remember, we need to specify 2 other parameters here. So we need to spec in the multisig wallet.address. I forget, I'm just going to copy it. Dot address. And actually, before this, we also need to specify the instance of the factory. So these are the 2 things that we need to pass in. So dot address. And the reason we need to pass in the factory is because we need to let the wallet contract know that we want to access the get the factory, so we can use the add wallet owners function in there. And if we run this, you'll notice that boom, that was successful. So now if we come back to the multisig factory and get the accounts, then you see that accounts 1 now has access to this wallet. And let's just say we come in here and we, instead of adding the wallet owner, we remove them. Then you'll notice that if we get wallet owners, then he no longer has access to that wallet. So when we create a UI and we use this method to display all of the owner's wallets, then he will no longer have access to it. So let's just redo it here. So we'll say, we'll try one more thing. So we'll add wallet owner, and let's go multisig wallet, or actually, let's go multisig factory. So multisig factory. And let's go create new wallet. And we'll create new wallet as accounts 0, 1. And we actually, if you want to ever, so if we were to call this function just like this, this would create a new wallet as if account 0 was calling it. So if you don't specify anything, then it will default to account 0 as message.sender. But if we want to call this function from any other of our accounts, what we can say is we can write 2 curly brackets and specify that we want to call this function as accounts 1. So we say from, and then accounts 1. And then this will effectively let message.sender equals accounts 1. So if we run this, and now we go and we get the wallet owners for accounts 1, you'll see that now he has access to this wallet, and we've initialized them to this wallet. So the adding and removing of permissions for different accounts to different wallets seems to work. So now that works, let's just actually see, can we do the regular functions like create, transfer, cancel, transfer, all of that stuff. So I'm going to come in, and I'm going to get wallet owners, and we have 2, so let's add one more wallet owner. So we'll add wallet owner, and we'll add accounts 2. And if we get wallet owners now, you'll see we have 3 wallet owners. So now let's go and see, can we deposit in some ether? So we'll say multisig wallet, and let's say .deposit. And we're going to deposit in some ETH first of all. Let's see, can we do ETH? And when I'm just going to throw in a dummy value here, because if we go to the contract and we go to deposit and deposit, yeah, so if we go to deposit here, you'll see that if we're depositing ether, then the balance is going to be incremented by message.value, not by this amount. So we can just throw in a dummy value here for the amount, since we're only depositing ether. So you can type in anything here. I'm just going to type in 0 just to make it extra obvious. And if we want to ever call or send ether into a function, what we do is we specify these curly brackets. And remember when we said from, when we want to specify a specific address to call the function? Well, we can specify an ether value by saying value, and then we could pass in like 1 ether like this. But remember, ether is denominated in way. So if we wanted to pass in 1 ether, instead of typing out 18 zeros, what we could do is we can type web3.utils.2way. and we want to put 1. We want to convert 1 into way, and then we just specify ether because ether has 18 decimals. So if we specify ether, then it will know to convert this 1 into 18 decimals. And we run this, and boom, the deposit was successful. So now we can say await. Now we can say await multisig, and we can say .get balance, and we can pass in the ether, because we want to get balance of ETH. And remember, if we don't specify a from address, it's just going to call this function from account 0. So, okay, so if we call the balance, you'll notice it gives us this crazy number. And this is because JavaScript can't handle big numbers. So what we could do is we could say let bal equals, and then just grab this, and then run this, and then we can say bal.toString, like so, toString. And then boom, this will give us our 1 ether. So now that we've deposited, let's actually create a transfer request. So we'll say await multisig.create transfer, I actually think I spelt this wrong when I was doing it, so I'm just going to come down and copy it from here. So create transfer request. So we'll go multisig.create transfer request. We want to create it for ether. We want to send it to accounts 1. This should fail because accounts 1 is an owner. And we want to send an amount of webtree.utils.toWay, and we'll send 0.5 ETH. So 0.5 and ether. And boom. This fails. Does it give us a message? I can't remember. Yeah, cannot transfer funds within the wallet. So we'll do accounts tree here because we know he has nothing. So if we do it to accounts tree, then boom, it works. And if we go and we get our balance again, so let bal, or yeah, we can't declare let twice. So if we want to get it again, we just take out the let. So we'll say bal and then get bal.toString, and you can see now we have effectively created a transfer. The funds have gone out of our account, but if we go and we get the bal of accounts tree, or was it tree we sent to? Yeah. Then you'll notice that it'll be 0 because the transfer hasn't been approved yet. So let's try and do that. Let's go await MultisigWallet, and we'll say dot approve transfer. I don't know, is it approve transfer request or approve transfer? It's approved transfer request. And its ID of 0. And let's try and approve it from accounts 0, the person who sent it. Oh, I forgot my comma. And that should fail because we can't approve our own transfer. It doesn't give an error message. Maybe I just forgot to type one in, but it should work now if we try and prove this from accounts 1. And boom, it does work. So now if we say await multisig.get transfer requests, like this, you'll see that it has 1 approvals. So if we go and approve this from accounts 2, then that should go true. And then if we get the transfer request, there should be an empty array because it got approved and we popped it off. So if we go and we get bal, if we let bal equals accounts tree again, and then we get bal.toString, you'll notice that he now has 5 or 0.5 ETH. So that transfer works for ETH. So now let's see if we can transfer link. Now remember, we haven't added link to our wallet yet. So we need to add link, and then we need to approve the multisig wallet to spend it before we can actually do a transfer. So if we go await and then multisig.add token, and then let's try and pass in a dummy token like X and then link.address. This should fail because we didn't pass in the correct ticker. So if we come in and we type in link, then boom, we've added link to our multisig. So if we say await multisig.get token list, you'll see that we have ETH and link. So now we can approve our multisig wallet to actually spend link. So let's see if that works. So we'll say await we'll say await link dot approve, and we want to approve our multisig dot address we'll approve it for a crazy amount. Like we'll just do a shorthand way of saying web3.utils.toWay, and we'll just do 1 and ether. So I'm going to approve, since I specified my link token to have 18 zeros, then one link is effectively 1 and 18 zeros as well. So I'm going to approve it just to have 1 ether. It doesn't, the value has nothing to do with it like it does in real life, but it's just because ether has 18 zeros and link has 18 zeros. Then I'm just going to approve link, or my wallet, to be able to spend 1 by 10 to the 18 link. So if we do this, web3 there, then that was successful. So now if we come back up here all the way to our deposit, yeah, and then what we can do is we can take out the brackets here, because we're actually depositing link this time. So if we pass in link here, then it's not going to go into the if statement where we say if token equals ETH, then update by message.value. It's going to go to the link part where it's just going to update by the amount. So let's copy this here just to save me typing it out again, and paste it, and we'll do 0.2. What's wrong? Okay, so I'm missing a bracket. Is it tree? Ugh. Sorry, I'm making a mistake here. Await multisig.deposit link web3.utils.toWay 0.2. I'm just going to type out the whole thing. Link, and we'll say web3.utils.toWay, and we'll specify 0.2 and ether, like so. Okay, I don't know why that wasn't working the first time. So now if we come in here and we go and get our balance, so if we say balance, and we'll say link this time, and then we go from accounts 0, and then we say bal.to string, you can see we have 0.2 link. So now let's create the transfer request. So we'll just come back up here to where we create the transfer request. And we just need to change this from link, or from ETH to link, and we don't have 0.5, so we'll say 0.15, let's, for example, and create the transfer request. Boom, this was good. And if we now come and approve it, let's say so the ID is going to be 1 this time, and we approve it from accounts 2. Boom, that works. Let's approve it from accounts 1. Boom, that works. Now let's go and get our balance. So where's my balance? So we go bal, and we do this again, and then we say bal.to string, like this. Bal.to string. So you can see now that we had 0.2, and then we minus 0.15, so we only have 0.5 link left. And let's do the same for Bal. We'll do accounts 3 this time, and then we come in here and we get Bal, and he has 0.15. So that is our tests work. So I know that this was I was moving a bit quick, and this was a sort of more complex topic, but smart contract testing, I'm going to do my own course on that really in detail. I actually might do it with this multisig factory example, or multisig example, but I'm going to do it in its own playlist, because I could do 10 videos of testing, and really robust testing, and showing you how to build out advanced migration files and all of this stuff that really is not what I want to focus on in this course. So that's why I did it really quickly there. And don't worry, that seemed so tedious, but you could just write a script to do all of this. But don't worry, the more you do this, you'll get used to it. But I just wanted to make sure, absolutely sure, that our contract worked. And yeah, so the next video is going to be the sort of second half of the sort of in-between phase between us doing the smart contracts and starting the UI. So in the next half, what we're going to do is we're going to set up our front-end development environment, whereby I'm going to be downloading or npm installing Sass, which is like it's sort of like CSS, but you can use variable keyword or variable names and all that stuff, and it's just much better than CSS. So we're going to be setting up our HTML files, we're going to be setting up our CSS and a few different scripts, and we're going to be downloading a few dependencies such as Bootstrap and other things, just so we can start the development of our UI. And then after that video, we're going to start actually implementing or integrating Web3 using web3.js, so we can connect to our contracts and, you know, hook up buttons to execute functions from our smart contracts such as deposit and withdraw and all that. So yeah, guys, that is all I wanted to say. So yeah, if you wouldn't mind just liking this video and subscribing, because it really helps out with the channel. So yeah, if you could do that, guys, I'd be very appreciative, and I'll drop up the next video maybe tonight or probably tomorrow, because it won't take that long. So yeah, I will see you then.